I am going to review trig functions and what we're getting into here in Unit 7, because I know at times this can get confusing. The buzz lesson is pretty good in helping to remember a lot of this. I like the little story with coming upon the two hikers lost out in the woods and coming upon this group of people with weird names all chanting Sokotoa, Sokotoa. It does a pretty good job of just kind of giving you something to go by. But I want to go through some of the specifics on how it works, how these trig functions all fit together, and what they mean. And we're going to do this by starting out with just some basic terms that we use in this unit. And I'm going to draw a right triangle. Notice I'm not constructing it, I'm just drawing it. Okay, here's the number one thing to remember when we're dealing with the trig functions. They only apply to right triangles. If the triangle does not have a 90-degree angle, trig functions do not apply. They do not work. They will not give you the correct answers on whatever you're trying to solve. Right triangles only. Okay, so that's what we're dealing with in this unit is right triangles, because otherwise there's no need to even try them. We will use some basic terms. Let me put these words up here, and then we'll discuss them because we have to make sure we know what they mean. Opposite and adjacent, and then the other is that odd word that we use in math, hypotenuse. Hypotenuse. Now, the hypotenuse is another word that only applies to a right triangle. If you don't have a right triangle, you do not have a hypotenuse. You do not have a hypotenuse unless you have a right triangle. And the hypotenuse is always the longest side of a right triangle, and it is always across from the right angle. It is this side right here. So if you didn't know what a hypotenuse was before, now you do. It's not an animal you find at the zoo. The hypotenuse is the longest side of a right triangle, and it is across on the other angle, for the other side from the right angle. Okay, it's across there. So notice the hypotenuse does not touch the right angle. This side touches the right angle. This side touches the right angle. So that's another way to look for it, is it's the only side of the triangle that does not make this angle. Right? So it is the far side. And I'm going to go ahead and just put a highlighter on hypotenuse. The hypotenuse never changes. When we talk about the sides of a right triangle, the hypotenuse is the hypotenuse is the hypotenuse. Now, let's talk about these other two words I have here, opposite and adjacent. Opposite, that's a word kind of common. We use the word opposite from time to time. It means, you know, the exact different thing of whatever you're talking about. I'm saying this and you're saying the opposite. Okay, in a triangle, opposite means whatever's on the other side, right? The opposite is the other side. Just like we use the word in common vernacular here. So in a right triangle, we're talking about one angle or the other, right? So let's say, for example, let's label our triangle as the ABC triangle. Okay, and I'm talking about angle C. So I'm talking about angle C, that means I'm discussing this angle right here. All right, so I'm going to mark this with the color, angle C. Now that I have an angle that I'm talking about, we can talk about which side of that triangle is opposite. It's not the hypotenuse. The hypotenuse is always the hypotenuse. But opposite would be the other side over here. This is the opposite side of the triangle from angle C, right? From angle C, that's the opposite side. Again, it's way over here. It doesn't touch the angle C. These two sides touch angle C. Opposite, farthest away. It's the side farthest away from the angle. It's the opposite side. We've got this side of the triangle. We've got this side of the triangle. It's the opposite side. Adjacent. Adjacent means next to. right? If we have two things that are adjacent to each other, we expect to find them right next to each other. We don't find them in opposite corners of the room if they're adjacent. We find them in the same corner of the room or the same two corners touching each other. So adjacent is the side of the triangle that is right next to the angle, right? This side right here is right next to this angle. Now, the hypotenuse is also next to the angle, but it's the hypotenuse. It does not change. Like I said, it's always the hypotenuse. This is the adjacent side. This is the opposite side. And that is true only when we're talking about angle C. That is the opposite side, and that's the adjacent side. Because if I stop talking about angle C, and now I want to talk about angle A, all right? I'm going to talk about this angle here, angle A. If I'm talking about angle A, is this side opposite of angle A? Not at all. This side is opposite of angle A. Right? For angle A, that is the opposite. That's the side that's the other side of the triangle. And so this side becomes the adjacent. So opposite and adjacent are terms that will apply depending on where you're at. If I'm over here in this corner, look at the triangle, I have to apply the opposite as this side. But if I change and I go up in this corner, now this side becomes the opposite. And that's important to know. That is, if you don't get this part, you're going to struggle all the way through the trig functions, because you have to know which is opposite and adjacent, and know that those change depending on which angle that we are talking about. So that is the key part that you have to know right up front, is which side's adjacent and which side's opposite, and know when to apply those terms to a side. Is this adjacent or opposite? Well, it depends. Which angle are you talking about? Okay, we got that. That makes some sense. Okay. In that case, let's move on and let's talk about what the trig functions are. Here's what they look like. You see the triangle we have here with opposite and adjacent, and it says the three main trig functions we use are sine, cosine, and tangent. And we have definitions. Sine is the ratio of the side opposite of the angle over the hypotenuse, and we abbreviate it SIN, sine, SIN. So here it is as a mathematical formula. The sine of angle F, so we're talking about this one here, it's mark the angle F. The sine of angle F is the opposite divided by the hypotenuse. You represent it as a fraction. It's opposite over hypotenuse. It's a fraction. It's opposite divided by hypotenuse. So if we actually wanted a number for that, we would put it in our calculator and take the opposite and divide it by the hypotenuse, and it would give us a decimal. That is the sine equivalent for angle F. Right? Opposite. So for angle F, the side that's up and down here in our right triangle is opposite, and the hypotenuse is always the hypotenuse, is always the hypotenuse. So cosine, this is one of our other main terms. It is the ratio of the side adjacent to the angle of the hypotenuse. So it's the adjacent divided by the hypotenuse. Adjacent would be the top side of this triangle as it's illustrated, because it's right next to the angle F. So the cosine of angle F is the adjacent, the top side divided by the hypotenuse. Now, our last term of our three primary terms is tangent. So it is the ratio of the side opposite the angle over the side adjacent to the angle. So tangent of angle F would be the opposite divided by the adjacent. Opposite divided by adjacent. So that's the combinations we have of sine, cosine, and tangent using the three sides of the triangle. Using those three sides. Okay, so let's put that into action with an actual triangle, some numbers on it. So I'm going to move down here and we're going to do another triangle. All right, I'm drawing another right triangle. And let's say the sides of this triangle are 3, 4, and 5. Okay. And we're going to talk about this angle right here. I'm going to name this L, M, and N. So angle N. And we're going to talk about some actual numbers to say, all right, if we wanted to find the sine of angle N, What does that equal? So we said in our definition that the sine was the opposite, I'm going to abbreviate opposite, over the hypotenuse. It's the ratio. So what is the opposite? What is the length of the side opposite of angle N? Well, opposite over here, it's a 3. And what is the hypotenuse? The hypotenuse is always along the side 3/5. So the sine of angle N is 3/5. And if you put that in your calculator, it'll say it's 0.6. But 3/5 is if we're just asking for the sine, in general, we'll put it as a fraction unless we're in buzz where it's giving us multiple choice in a decimal, then we just convert that to a decimal. 3 divided by 5, 0.6. That's the sine. The cosine of angle N. What's the cosine? Remember, the cosine is the adjacent over the hypotenuse. Cosine is the adjacent. Well, this is the side that's right next to angle N. So that's a 4. And the hypotenuse is always the hypotenuse. 4/5, or 0.8. 4/5 is the cosine of this angle. The last one was tangent, T-A-N, angle N. Tangent, remember, was the opposite over the adjacent. Opposite was the 3. The adjacent was the 4. So 3/4 is the tangent of that angle, or 0.75 as a decimal when you put that in a calculator. So that is our sine, cosine, and tangent for this triangle when talking about angle N. What if we changed and made it angle L instead? If we moved over here, all right, we'll move to angle L. Well, the sine of angle L, is it also 3/5? Because it's opposite, still the opposite of the hypotenuse. That didn't change because that's what sine always is. Sine is always the opposite of the hypotenuse. But for L, 3 is not the opposite side. 3, the opposite side for L is the 4. The hypotenuse is still the same because the hypotenuse never changes. So sine of the other angle is 4/5, which is what the cosine was here. Because the cosine used the adjacent side of the hypotenuse, but for the other angle, the adjacent side over here becomes the opposite side. So it's 4/5. So the cosine for angle L is the adjacent side of the hypotenuse, and it is the 3/5. So those two traded. The sine became the cosine became the sine, because we moved angles and the opposite and adjacent traded places. Because we traded places. If you're going to stay opposite and I move to your side, you got to move to my side. And then the tangent, what happened to the tangent? I think L. Opposite over adjacent. Now it's this one over this one. It's 4/3 instead of 3/4. It just reversed itself. Opposite and adjacent trade places. So opposite and adjacent trade places. So that doesn't change. Opposite over adjacent. Just the numbers change because we relabeled them when we changed angles. All right. That's a key thing. Just remembering the opposite and adjacent will trade places depending on which angle we're asking about. So it's very important to know which angle the question is asking about when you're doing these problems. When you're doing problems, if you don't pay attention to which angle is which, and you just start throwing numbers out there knowing opposite of a hypotenuse, you don't know what opposite is if you don't pay attention to that. So these are the ratios we said. Said ratio. The ratio is 3/5, 3/5. That's a ratio. This is 3/5 the size of this one. That's what we said. It's a ratio, and ratios can be represented as a fraction. 3 to 5. If we cut this into 3 lengths that are equal, it would be 5 of those lengths to exactly equal the other. It's a ratio of 3 to 5, or 3/5. It's a ratio of 4 to 5, 4/5. These are ratios. So we see that illustrated right here. All right. So that's where acronym comes in. Our lesson talks about SOHCAHTOA, because it's like, how do I remember that sine is the opposite over the hypotenuse, that cosine was the adjacent of the hypotenuse. I got to remember all of that. So it talks about this acronym. So, pronounced so, stands for sine opposite hypotenuse. The ka stands for cosine adjacent hypotenuse, and toa stands for tangent opposite adjacent. SOHCAHTOA. If you can remember SOHCAHTOA, put this in your notes. Like I say, you can use notes on all the assignments, quizzes, tests. Put this in your notes, SOHCAHTOA. And remember, SOH means sine opposite hypotenuse. Sine equals the opposite over the hypotenuse. They go in order. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. SOHCAHTOA. How do I remember SOHCAHTOA? I don't have my notes. Well, lots of people have come up with different ways to remember that. Here's just one quick list. I Googled and pulled it up in 5 seconds, had this list of different ways you can remember SOHCAHTOA. And I highlighted some of my favorite. She offered her cat a heaping teaspoon of apple juice. And just look at the first letters. This is an acronym for the mnemonic. She offered her, S-O-H, so, cat a heaping, C-A-H, ka, teaspoon of apple juice, toa. She offered her cat a heaping teaspoon of apple juice. Some old horse caught another horse taking oats away. Some old hairy camels are hairier than others are. Some old hags can't always hide their old age. Summer on holiday, Christmas at home, teachers off anyway. I go. And then my favorite there at the bottom, some old hippie caught another hippie tripping on acid. Yeah, there's a whole bunch of them. If one of them kind of sticks in your mind, it can help you remember SOHCAHTOA, just using the first letters of each of those. So, pick your favorite. Find a way to remember SOHCAHTOA because it helps you to remember all that. And I'm going to get to that in a second. Let's go back to some more examples. So we talked about it being a ratio. So let me look at another real quick. What if we went back to this same triangle? I'm going to do the same triangle right here real quick. There's 3, 4, and 5. And we said the sine, if we looked at this angle, and a lot of times you'll see this with just the name of an angle in here. This is theta. It's a Greek letter. So if I said the sine of theta degrees, that's degrees. Sine of theta equal, so we're talking about this angle, the sine, remember, so sine is opposite over hypotenuse. Opposite is 3. This is the longest side, it's 5. It's easy to tell what the longest side when they tell you the lengths, 3, 4, 5. Which one's the biggest number? Nope, must be this side, it's the hypotenuse. I said that's a ratio. What if we dilate this and we make it bigger? All right, I'm going to make this a bigger triangle. I'm going to make everything this long and twice as tall. So it's still a right triangle. I just, instead of 4, now this whole length here is going to be 8, right? And this height, instead of 3, this is 6 tall. And this over here is a length of 10, all right? So this triangle, this is 10. We made it twice as big. This is 8. We made it twice as long. All right. Well, let's look at the sine. If it's a ratio, it shouldn't change. The ratio is how big is this compared to this. And if we look at this angle is exactly the same in both triangles. Can we agree on that? The angle for the little triangle and the angle for the big triangle? Because it uses the exact same angle. This angle didn't change at all. It's the same angle. So the ratio should be the same. So what is the sine of the big one? The opposite, sine of theta, equals the opposite, which is 6, over what's the hypotenuse now? On the big one, the hypotenuse is 10. 6/10. Well, that simplifies. We can take a 2 out of the top and bottom. That simplifies to 3/5. Hey, that's the same thing. Still the same ratio. When you put that in Buzz, don't ever put a fraction that can be simplified because Buzz will count it wrong. 6/10 simplifies to 3/5. So the sine of theta for the little triangle is 3/5. The sine of theta for the big triangle is 3/5. It's the same ratio because those are similar triangles. The shape of the triangle did not change. It's still a right triangle, right? And all these two right triangles, since this one's nested inside, it's certainly going to be the same. These are similar triangles. And so the ratios should be the same. In a similar triangle, all the angles stay the same. The ratios should stay the same. And they do. We see that with the sine of both triangles, right? So that should give you a little better understanding of what that's talking about. A little better understanding what I was talking about. I do want to talk briefly about the other trig functions that we're doing in this lesson today. And I had those up on the screen briefly a moment ago. Let's put those back up. Okay, the other ones we talked about is cosecant, secant, and cotangent. And those are just the reciprocals, which means we turn upside down, basically, those fractions. The reciprocals of sine, cosine, and tangent. So the reciprocal of sine is the cosecant. Cosecant is the hypotenuse over opposite, right? Sine was the opposite over the hypotenuse, remember? SOHCAHTOA. Cosecant, which is sine's reciprocal, is just turn that fraction upside down. It's hypotenuse over opposite now instead of opposite over hypotenuse. The reciprocal of cosine is secant. So you turn that adjacent over hypotenuse, turn it over, it's now hypotenuse adjacent. And the reciprocal of tangent is cotangent. Those are easy to remember, that tangent and cotangent go together. These, you want to put this in your notes. Cosine and secant, sine and cosecant. That's not instinctive because this is the one that starts with COS, but on the other one, it goes with the sine. Cosecant is actually the reciprocal of sine. So the cotangent is adjacent over opposite instead of opposite over adjacent. So make sure you have this in your notes too, because when we go back and look at our triangle that we just had up here, the sine is 3/5. If we want to look at the cosecant, right, the cosecant, which is the reciprocal of that, it's the hypotenuse over the opposite. So the hypotenuse, we're looking at the big triangle. Let's look at the small triangle. The hypotenuse is 5, and the opposite is 3. Notice it's the reciprocal of the sine. Cosecant is the reciprocal of sine, which means another way to write sometimes you'll see it written like this. If we're talking about the cosecant, it's the same thing as 1 over the sine. So the cosecant of theta is the same as 1 over the sine of theta. And in this example here, 1 over 3/5 is the same as 5/3. If you take 3/5, which is 0.6, and you divide 1 by 0.6, you'll get 5/3, which 5/3 as a fraction is 1.6 repeating, 1.6 repeating. So 1 divided by 0.6 is 1.6. These are equivalent. 1 over the sine is the same as the cosecant of an angle. Okay, so that little piece of information can be useful there. So you want that in your notes as well. All right, so let's look at all of them with the same triangle. So the 3, 4, 5 triangle, this one's turned where the 4 is the up and down, where I had the 3 up and down the way I do it. Here's all 6 trigonomic ratios for triangle ABC, and we're looking at the angle C, which is the 53-degree angle. So for this 53-degree angle, angle C, the sine of C is 4/5. The cosine of C is 3/5, because it's the adjacent side right there next to the 3. And the tangent's opposite over adjacent, 4/3. Then you see the reciprocal function. Cosecant, abbreviated CSC, cosecant, hypotenuse opposite, 5/4. It's exactly the reciprocal of the sine. Secant, opposite of cosecant there, it's a reciprocal. Hypotenuse over adjacent, 5/3 compared to 3/5. And then the cotangent, adjacent over opposite, 3/4 instead of 4/3 that the tangent was. All right, that makes sense. If you need to go back and review any of this video, please do. But remember, if we change all this now and we leave C and we talk about angle A, all of these will change because our opposite and our adjacent sides change. If we go up to the 37-degree angle, 3 is now the opposite. And so sine will become 3/5 instead. And that means cosecant will become 5/3 if we talk about angle A, which is 37-degree angle. So it all boils down to what angle we're talking about and what is the function we're talking about. We're talking about sine, we're talking about tangent, we're talking about cotangent, any of that. What are you trying to get to? All right, I'm going to talk about one more thing that you'll run into in this lesson, and that is how to find one of the sides when you have some information. Let's say, for example, we have, and I'm going to draw, sometimes you see it like this, where this is the right angle, right? Sometimes they'll do it like that. They'll just lay it on its side. They'll flip it where the hypotenuse is down here. And let's say we have this angle and it's x degrees. Okay, x degrees right there. And the hypotenuse on this one is going to be 47 long. And we're going to say this side is 26. And that's what we know right there. And it says, okay, on this one, it says, what is x? So this one, we want to know how many degrees. We're not finding the side on this one. We're finding how many degrees is that angle. And it's given us two sides. And we're like, well, I don't know how to find that. Well, you think of our functions. Go back to the SOHCAHTOA and figure out, first off, what sides do we have? We have, there's the right angle, we have the hypotenuse. Okay, we have the hypotenuse. So that means we can use either sine or cosine. Tangent doesn't use the hypotenuse. You use sine or cosine. Which side is 26? If we're trying to find x, that is the opposite. So we have the opposite and the hypotenuse. So we know that the sine of x degrees is going to equal 26 divided by 47. And we can find out what that is with our calculator. We can say 26 divided by 47. That is 0.553. 0.553. Like, okay, so I know the sine of this angle is 0.553, but that doesn't tell me what that angle equals. Well, this is where, in our calculators, and I haven't looked at Buzz's calculator. I try to always remember to put that up where you can use that. There is this little, above the sign usually, there is a little sign, and it'll look like this. Sign, and it'll have a little -1 over it, or something along that line. See if I can get this up close enough to see it. See a little sign, -1, cosine -1, tangent -1. It's called the inverse sine, inverse cosine, inverse tangent. And what that button does is it says, if I know that something equals 553, I can use this button to tell me what that something is. Basically, it works backwards for you. So if I take what I have, 26 divided by 47, I knew that was 0.553. If I take the inverse sine of 26 divided by 47, or I could put in the 0.553, but this way, if I put the original fraction, I'm not rounding. I've got the entire 553, all those numbers after that. So what is the sine inverse of 2647? It says it's 33.58. So x equals 33, and we'll round it to the nearest tenth in this example. Say 8 will be rounding up. So x is 33.6 degrees. We found out how many degrees that was by using the sign and that little inverse button, inverse right there. The sine inverse of 2647 is 33.6. There's 10. So if we know what it equals, this will help us fill in the blank. It helps us fill in the blank. We use that, the sine inverse of 26 over 47 equals 30.6, which is our degrees. All right, so that's what that function is on the calculator and how we can go backwards and find that information. Very, very useful. Very, very useful. Okay, something else that we have, maybe perhaps at some point, because I talked about finding a side. You may have a problem that has, let me draw this one, a right triangle. And on this one, let's say we know that this is 19 degrees. And we know that this side is 76 yards. We have yards here. And we need to know how far that is. All right, this comes from our example where they're lost in the woods, and there was a footpath that was right here, and there was a rock down here, and they were trying to figure out how far is it that you go off the footpath till you get to the right rock, because there's rocks all over the place in the woods. They're not know this map they had showed them this and tried to figure out how far do I go to this rock from the footpath. They need to know how far to go, and their campsite was back here, right? So here was their campsite. They go down this footpath, and then they got to go to this rock. So they got to figure out how far it is off of there. All right, well, let's see what sides are we dealing with. This is a right triangle, so we can use our SOHCAHTOA, use our trig functions. This is the hypotenuse, right? It's the across from the right angle. We have the hypotenuse. What side is x? Well, the only angle we have is 19, so we're using the 19-degree angle. That is not the adjacent, right? Adjacent is the one that touches it. The angle touches the hypotenuse and the adjacent. Hypotenuse and the adjacent. That's what makes this angle all the time. Hypotenuse and adjacent. So this is the opposite. So we have the opposite. So if we set up our equation, like our normal sine equation, the sine of 19 degrees equals the opposite is x. The hypotenuse is 76. That's the equation. That's sine. Sine is opposite over hypotenuse. Sine of 19 degrees, since we know the angle, sine of 19 degrees equals the opposite over hypotenuse. Now we have to solve this for x. We need to get x by itself. We need something that says x equals, and what does x equal? So how do we get x by itself when it's being divided by 76? We have to multiply by 76, which means we have to multiply over here by 76. So that will cancel out. Dividing by 76 and multiplying by 76 leaves us just x. So x equals 76 times the sine of 19 degrees. That's what x equals. Now, does that help them know how many feet or how many yards to go off the footpath? Not yet. You can get a number with this because of our lovely calculator. We have our calculator that we can say, okay, what is 76 times the sine of 19 degrees? 76 times the sine of 19 degrees. Now, here's one little important thing. Anytime you're using a calculator, if you're doing this, you have to make sure you're in degrees. Can you see a little DEG? Have to make sure you're in degrees. You got to change your mode. There's a mode button, like if you have a TI-84 or something, there's a button that changes that. And this one's got a degree button right here. But make sure that you're in degrees, because this 19 is degrees. So if you're in a different measuring format, you're not saying 19 degrees, you're saying 19 radians or whatever mode your calculator is. So make sure it's in degrees. So 76 times the sine of 19 degrees equals 24.74. So x equals 24 point, and we'll go to 2.743, so it rounds down. X equals 24.74. This is 24.74 yards. So what I'm doing, in assignment and buzz, and if it's got multiple choice, then I would look for this number. or if it's rounded, you know, they round that down. Or if this is a open response, I put this work. That sine of 19 equals x over 76. Then I multiply by 76. So x equals 76 times the sine of 19 degrees. And there is my x. That's what I calculated to be with my trusty calculator. That is the answer. So that's how we find a side when we have the degrees and we have one other side. You know, if they didn't give us this and they gave us this one instead, if we're opposite and the adjacent, then we would use tangent, right? You got to figure out which one of these functions I'm using. If I had x in this side instead, I would use tangent. If I didn't have the x here and the x was here and I had the adjacent and the hypotenuse, I would have used cosine. So I'm just figuring out which one of these I'm using, sine, cosine, or tangent, based on the information given to me in the problem. Because I need to set up that sine of 19 equals, or cosine of 19 equals, whatever. So that's what you need to do. If you have problems with any of this, when we're in class, come on in. It's optional if you're above 70 degrees, but that doesn't mean you can't hop in there and say, hey, Mr. Brock, I need some help. Of course, if you're below 70, you'll be in there anyway, and just yell at me if you're stuck in trying to do some of this and not understanding what you need doing. But I want you to succeed in this. I want you to understand it, and hopefully this video will help you with that. So I will end this now, and review whatever you need to on this, and look at the lessons. There's more in the lessons than what I gave you. I gave you a brief overview to help you understand the lessons. That if you don't get the opposite adjacent stuff, then you're going to be lost. So make sure you understand how to tell which is opposite, which is adjacent in your triangle, because remember, it changes. All right, until next time, do work you can be proud of.